Okay. Inscribed angle. Inscribed is inside. Inscribed angle is an angle whose vertex is on the circle. Circle and the vertex. Vertex is here. So these two segments, they are forming an angle. And because this angle is inside the circle, this is inscribed angle. The angle that is formed with the center, the radius, these two segments, they are nothing but radius. This is the central angle. But this is inscribed angle because this is formed by the segments and the vertex is on the circle. It is not in the center. Vertex is on the circle. Inscribed angle. The arc formed by these two lines or segments or rays, they could be anything. This arc is called intercepted arc. An arc that lies between two lines, rays, or segments, because it can be anything. If you extend it, it can form anything, is called an intercepted arc. A polygon is an inscribed polygon when all its vertices lie on a circle. All these vertices, they are on the circle. Inscribed angle, intercepted arc formed by these two segments. This is central angle. Central angle is different from inscribed angle. Now, this theorem, inscribed angle of a circle theorem, what it says, if two inscribed angles of a circle intercept the same arc, that means they are forming the same arc, then the angles are congruent. If you say this one, this inscribed angle is formed by segments DA and DB, and they are forming the intercepted arc as AB. Let's consider this inscribed angle. This inscribed angle is formed by AC or CA and CB, and this inscribed angle is also forming the same intercepted arc, which is AB. Because these two angles, they have the same intercepted arc, these angles are equal. Another thing, the measure of an inscribed angle is 1/2 the measure of the intercepted arc. This will be 1/2 of the intercepted arc. This is intercepted arc, this is intercepted, this is inscribed angle. Let's try. In this case, they are asking us find angle B. Angle B. This inscribed angle is forming this arc AB, AD. Angle ABD, this angle is also forming the same arc. From this theorem, when the two inscribed angles, they have the same arc, then the inscribed angles are also equal. To apply that theorem here, these two angles, they are forming the same arc, which is arc AD. So we can say measurement of angle B is nothing but 68 degree, which is nothing but C as well. Let's try a few more. Okay, let's try these two theorems. According to this theorem, if a right triangle is there inside the circle, that means if a right triangle is inscribed in a circle, then the hypotenuse will be the diameter of the circle. If this is a right triangle, then AC is the hypotenuse and AC is nothing but diameter. Angle ABC, measurement of angle ABC is 90 degree because the angle opposite to hypotenuse will always be 90 degree. If and only if AC is a diameter. Because in this case AC is a diameter, that is why angle ABC is 90 degree. Because it is 90 degree, this is nothing but hypotenuse. What happens when we have quadrilateral as our is inscribed inside a circle. If a quadrilateral is inscribed inside a circle, then the opposite angles, they are supplementary. Opposite angles, they will add up to 180 degree, because supplementary is nothing but 180 degree. Angle A plus C, so measurement of angle A plus measurement of angle C will be 180 degree. And the same way, measurement of angle B plus angle D will be 180 degree as well. Angle B plus angle D will also add up to 180 degree. Let's try a few questions. Okay. In this one, they are saying red. Okay. They are asking, find the measurement of the red arc or angle. This arc, and this is given to you as 90 degree. They are asking you what should be the angle, right? And if I'm not wrong, they are asking about this one. Okay. We have read that the measurement of the inscribed angle is 1/2 the measure of the intercepted arc. If I have to apply this, this is my intercepted arc. Intercepted arc is 90. I need to find the angle. Inscribed angle is 1/2 the intercepted arc. So 1/2 of 90 will give you 45 degree. So the inscribed angle is nothing but 45 degree. Let's try this one. Now, inscribed angle is 1/2 of the intercepted arc. Intercepted arc is VT. So do I know the intercepted arc? No. So intercepted arc VT and the inscribed angle is half of this one, is measurement of angle U. What is angle U? Angle U is 38 degree. Right? Do I know VT? No. But what I can do to find out? I can multiply 2 both the sides times 2. It will cross off. So VT is nothing but 76. Let's try this one. This angle Y is forming the intercepted arc WZ. Angle X is also forming the intercepted arc WZ. According to our theorem, if the two inscribed angles are forming the same intercepted arc, then the two angles are equal. Same thing here. If the two angles, they are forming the same intercepted arc, these two angles will be equal. So measurement of angle Y will be equal to the measurement of angle X. So angle X is nothing but 72 degrees. Right? Let's try more. Okay. In this case, find the value of each variable. I need to find this one. In this case, WY is a diameter, right? Radius and radius. Because it is a diameter, that means this triangle is a right triangle. It is a right triangle. WY is your diameter. And because it is a right triangle, this is nothing but hypotenuse. Angle opposite to hypotenuse is always 90 degree. Because it is opposite to hypotenuse and it is 90 degree, I can equate 5x degree is equal to 90 degree. And this is one step equation. Let's simplify. Divide both sides by 5. This will make your big one. So x degree is nothing but 18 degree. X is equal to 18 degree. Let's try this one. In this case, we have a quadrilateral inscribed in a circle. So when a quadrilateral is inscribed in a circle, the opposite angles they form supplementary angles. That means they add up to 180 degree. Let's apply the same principle. So opposite angles are 65 and B, and the another set is 3A and 111. Let's try. I can write it down as 3A plus 111 is nothing but 180 degree, and another equation will be 65 degree and the opposite is B plus B degree should be equal to 180 degree. These two are opposite and these two are opposite. Let's simplify it. Minus 111 minus 111 both sides, and you will get 3A degree is equal to, now divide 3 both sides. A degree is 23 degree. Let's try this one. I need to isolate my variable. So minus 65 degree, minus 65 degree both sides. Form 0 pair, just like this one. So B degree will equal to 115 degree. That is your answer. I hope